Hello and welcome to Easy Projects. Today I will attempt to repair this IKEA LED lamp because it doesn't work. And inside the lamp itself there's only 3 of these LEDs wired in series, and there's just a positive and a negative wire coming out of it. I'm actually pretty sure that the LEDs are working because they are flashing occasionally. But very conveniently the wire can be pulled out of the power supply, so we can test the LEDs. So I don't know if you can see that, but the LED is indeed lighting up in there when I apply some current to it. So at least we know that the lamp is fine and it's all to do with the power supply. And it is actually a proper constant current supply, and it should be that for LEDs. So I've tried to cut it open with a knife, but I didn't have much luck with that, so we might need some other tools. And here it is. And it looks like it's just an ordinary switch mode power supply. But this inductor doesn't look too good if you ask me. Also the mains connector's broken, but that's indeed not the problem. Or maybe the inductor here is actually okay, because this black gunk here looks like it's just the glue they used to hold it in place, because it's all over the place. It's not like it has vented out of the windings or something like that. So far the circuit design doesn't actually look too bad. There's plenty of circuit protection, and the caps they have used are actually rated for 400 volts on the input side and 25 volts on the output, and this will deliver a maximum of 15 volts, it says on the sticker. And they have also added a bit of gunk here. I don't know why they put it right there, but oh, now I get it. There's actually a swimming butch resistor in there. Okay, I might change my mind on the circuit design. What the hell is this? There's just large blobs of solder everywhere, and the resistors are just placed all over the place here. But the worst part must be this one. This is a transistor-like package. I haven't actually checked it yet, but it's this guy here. And 2 of the pins are shorted with a big blob of solder here. And that is actually the positive pin of the socket here, going to this middle pin. Okay, so that device is just an NPN transistor. And if we take a look at the board again, they have shorted the collector and the emitter with a blob of solder. Why would you do that? So that must be a mistake. There can be no way they did that on purpose. I mean, you don't design in a output transistor of that size, and then when you design the product and got to test it, you just, oh, we don't need it anyway, we'll just short it out. And there's also something called emitter base breakdown voltage, so if this base is not at the same potential as this, they might actually blow up the transistor and short this directly to here. And I just noticed another thing actually. I don't know if you can see at R2 here, there's some glue sitting on the sides of this unpopulated resistor footprint here. So that actually indicates that there have been a component here. Well, I don't know if it have just fallen off and I lost it when I took the case apart, or if it's never been there, but that could indeed be the reason why it doesn't work. And also, if this have been pulling too much current, it may have desoldered itself. So I just checked on this device here that the missing resistor here is in series with is an NPN transistor. So for this to work, I assume that resistor must have been there, but I have no idea about the value, so unless I can find the resistor, yeah, I don't know. Nope, I couldn't find any resistors laying around, but maybe they actually did this on purpose, because this transistor is connected to the base of this transistor here, and they shorted this one out, so perhaps they removed this resistor and shorted this here to get it to work. I don't know why they would do that and redesign the board, because that is... it must have been there for a reason. I mean, you can't just short out the output transistor when it's supposed to be a constant current supply. So I think I'll just throw this as far as I can and then make a new 350 milliamp constant current supply and just use a regular wall wart or something and add something after that to regulate the current. So I will just try to get a rough estimate of what voltage I need for the 350 milliamps. So I'll do that with the power supply here. Oops, it's saying unreg. What the hell is going on here? Oh, my sense terminal is loose. So it will need 10.5 volts for 350 milliamps, and I actually think I have a 12 volt AC to DC adapter that will give about 500 milliamps max. So I think we can use that one and then add a constant current circuit to that to generate the 350 milliamps. So let's take a look at that. And yes, I was correct. It was 12 volts at 500 milliamps. But I will just test it to make sure that it will deliver the 12 volts, because we need a bit of a margin. And it will probably do 14 or 15 at no load, and then at 500 it will do the 12 volts, hopefully. I don't think it's regulated, I just think it's a rectified transformer. Holy shit, 17.5 volts. That's a bit over the 12 volts, but I'm sure it will drop when we load it. So let's try to do that. So to load it, I'll just hook up a 27 ohm resistor. And at 12 volts that should give us 400 and some milliamps, but we can read the voltage and we can calculate the current if we want, but I don't really care, I just want to make sure that the voltage drops a little bit. And there we go, it's 11.6. Yeah, sorry, that was just me, I didn't take into account there was a drop in the leads. So I think one of them was a little dodgy, because there's actually 12.6 volts right at the connector. But just for good measure, let's measure the AC as well. Okay, so there's only about 1 volt. So there is indeed a capacitor in the transformer as well. So I think we will actually be able to use just an LM317 to make this constant current supply, because if we have about 12.6, 13 volts on the input and we need about 10.5 on the output, then that's about 2 to 2.5 volts at 350 milliamps that we will need to dissipate in this regulator, and that is about 0.7 watts to about just over 1 watt, so it can easily handle that. And very luckily, the easiest circuit to build with an LM317 is actually a constant current supply. And that is because this LM317 works in a way that it has a 1.25 volt reference internally. And for the output voltage to be stable, the output needs to be exactly 1.25 volts above the adjust. If this is too low, the output will rise, and if it's too high, the output will drop. And it turns out all we need to make a constant current supply is a resistor. And that is because of Ohm's law, because if we have a current through this resistor, that will make a voltage drop across it. And when that voltage drop is exactly 1.25 volts, then the voltage at the regulator will ensure that we get the 350 milliamps that we need. So we'll just connect that like that. And it turns out that this resistor needs to be 3.57 ohms. And that is just Ohm's law saying that voltage equals current times resistance. And we know the current and the voltage, and we need to find the resistance. So we just divide by the current on each side, so we get V divided by I, equals R. So that is 1.25 volts divided by 0.35 amps equals 3.571 something. And this resistor needs to be able to dissipate at least half a watt. So I chose two 12 ohm resistors and a 10 ohm resistor in parallel, and that's close enough. I didn't actually calculate it, but that will do. And this is our finished circuit, and I chose a 1 watt resistor for the 10 ohm and just quarter watts for the 12 ohms. And that will be good enough because we only need to dissipate a maximum of half a watt, so that's just fine. And this will probably be the most simple circuit that you will ever see on this block. So now we'll just have to test it and confirm that it is working. So I have hooked it up to the lamp here, and I've just connected it to the bench power supply just to make sure that everything works before we connect it to the wall wart adapter. I have set a current limit on the supply to 400 milliamps, but we should reach that. It should regulate to just under 350 milliamps. So let's try to turn up the voltage and see what will happen. And it starts to light up now at 10 volts, 12 volts, 13 volts, we're at 320 milliamps, 14 volts at 337, 15. Yeah, so it's regulating to 337 milliamps, 38. So that's just fine. But we will need, we need at least 13.1 volts, but I also have all these leads here that will create some resistance, but yeah, I don't know if we will be able to pull that out of the transformer. But let's try to connect it up and see what will happen. At least we have confirmed that it will not send out too much current. So I have hooked it up to the wall wart adapter, and let's see what will happen. So it does light up indeed, but I don't know if it is getting the 350 milliamps, so we will have to measure that. And we are getting 323 milliamps, so that is close enough. It is a bit under the rated current, but at least it's better than if it was higher. So I'll just need to put it in a box, and we can see the final result when I'm done. I decided to use this small box and just drill a hole in the side for the wires to come out, and then I just potted the whole thing with a mix of epoxy and hot glue. So there's no way this is going to break the solder joints or anything in there. Well, it is not that pretty, so maybe I will cover it up with something. But I think it will do the job. Let's try to plug it in and confirm that it still works. I think it does, but... And there was light. And yes, I have confirmed that this will not get so hot that it melts the glue inside. It only gets like 40 degrees or something when it's been running for 1.5 hours, so I don't think that will be a problem. But still, I really hope this was a mistake and not something they did on purpose. But anyway, we fixed it. Well, we didn't fix supply, but we made a new one, so that will do. And by the way, there's a fuse on this old board here, and that is not blown, so I did check that. I don't think I filmed it, but it has been checked. I guess that was all for this time, so thanks for watching, and if you liked the video, please give it a thumbs up and subscribe to my channel. See ya!